Hello, everyone, and thank you so much for joining the fourth of 9 lectures of this virtual PhD course on urban economics in developing countries. As those of you returning will know, this lecture series is co-hosted by the Bureau for Research and Economic Analysis of Development, or BREAD, and the International Growth Center. It's really wonderful to have you all back again to learn more about this really important and rapidly emerging area of economics research. I'm sure I will have spoken to many of you before, but for those of you who don't know, I'm Vicky Delbridge, head of the IGC Cities That Work initiative, and I'll be chairing today's lecture, which will be focusing on, I think, one of my favorite topics in urban economics, on transport and connecting the city. And to teach us something about this, we are very privileged today to be joined by Gilles Duranton, the Dean's Chair in Real Estate Professor at Wharton, as well as Gabriel Kreindler, Assistant Professor in Economics at Harvard. As usual, the lectures will be followed by 20 to 30 minutes of Q&A at the end. Before we get started, I wanted to run through some housekeeping items with all of you. So first, if anyone would like to act as a live participant during this lecture, meaning you'll have access to both your mic and video and be able to interact verbally during the Q&A, please, if you could virtually raise your hand, and Aman, our technical assistant, will randomly select a couple of you to join the discussion. For other participants, if you could type any questions you have in the Q&A box at the bottom of your screen, you can submit questions at any point during the discussion. It'd be great if you could include your name and organizational affiliation when you write your questions, just so we can bring you into the discussion. You can also please upvote questions by clicking the thumbs up icon on any questions you really do want to have prioritized to have answered at the end. I'd like to note that we're recording all lectures in the series, and the recordings will be made available on the IGC website, along with slides and reading lists from the lectures. Hopefully they should be available, the ones from today, by tomorrow on the website. Finally, for those who attend at least 7 lectures in the series, you'll be issued with certificates on completion of the course. So yeah, great to have so many of you returning back every week. So without further ado, I'd now like to hand over to Professor Duranton to lead off with the lecture, as Aman selects any of those of you who want to participate virtually. Over to you, Gilles. I think, Gilles, you are muted.
Oh, sorry. Thank you very much. Can you unshare your screen so that I can put on my slides? Okay, good day, everyone. It's really great to see such a large number of people and attending this. We are already above 400 participants. So this is a session this time on transportation, the connected city. Yeah, let me make sure I can actually move on with my slides. Yes. So, okay, sorry, there's a slight problem with the. Okay, let's try to hide. No. Okay, sorry, I had some pollution on my screen and I couldn't see anything. That's better now. So this is about cities and development, and everywhere in the world, in the developing world, especially in the rich world as well, cities are about connections. And those connections are really about going to work, when you're at work, visiting your suppliers, visiting your customers, or going from home or work to shopping, to schools, to seeing friends, going to government offices, enjoying some leisure outside of your house, especially after visiting the government office, worshipping, and so on and so forth. So these connections are actually why we have cities in the first place. They allow us for better sharing, matching, and learning of goods, be they consumption goods, intermediate goods, or public goods, of factors, especially labor, and ideas. So basically, urban connections are the very source of those things that we think are the reasons why we are cities, agglomeration benefits. And to function properly and to provide agglomeration benefits to its residents, a good transportation is necessary. Whatever good transportation infrastructure actually means, that's really what's needed for people to be able to access places in the city. So I'm going to share this lecture with Gabriel Kreindler. So what I will cover here in my 30 minutes is roadway infrastructure and determinants of travel time during the first half of my bit, and traffic congestion during the second half. Gabriel will cover public transit and broader effects of urban mobility. So let me start with some numbers just to illustrate what's going on. So I'm going to compare from the US National Household Transportation Survey. I'm going to compare with a household in a typical metropolitan area. So this household is going to take, or is taking 4.2 trips per day per traveler. Each trip is on average 13 kilometers long and takes about 17 minutes. Reported travel speed is close to 40 kilometers per hour, and overwhelmingly it's happening by car. Instead, in Bogota, using the Bogota Transportation Survey, which I'm familiar with, each traveler takes 2.7 trips a day. Each trip is on average about 11 kilometers long and takes close to 40 minutes. So that's much, much more. So reported travel time is 17 kilometers per hour, and cars and taxi are only about a quarter of all trips instead of close to 100%. So in poorer places, people take fewer trips that are shorter and slower. And this is going to be true much beyond Bogota versus the US. These are general features of rich versus poor cities. And when I say rich and poor cities, I mean cities in the richer world and cities in developing countries. So let's actually look at this. This graph is showing us throughout the day, from midnight to midnight, travel speed in 3 different cities. The first one is in the data that we have, which are extracted from Google Maps for 1,215 cities, so it's a large sample. The fastest is Flint, Michigan. Not that this is a place where most of us would want to live, but this is a really fast place, in part because of its urban decline. It has an oversized infrastructure. So you see that travel speed is about 50 kilometers at night, slightly less, 45, 46 during the day. Then the second city is Bogota. So Bogota, you see, is already slower at night, even when there's no traffic. Travel speed is whatever, close to 35 kilometers an hour. And then during the day, it falls to about 20 before we're going up again at night. Bogota is actually the city where the contrast between nighttime, i.e. uncongested travel, and daytime is the strongest in the world. So we call that congestion. That's how we're going to define congestion. This difference between travel time when there's no congestion and travel time when there is congestion. So you see that Bogota is actually, in our data, is going to be the most congested city in the world. And then the third one is Dhaka, Bangladesh. That's actually the slowest city in the world. Not that this is hugely congested, but it's the slowest because even at night when barely anyone is traveling at 3 a.m., you see that travel speed is just above 20 kilometers per hour. And the last one is actually a zoom on travel that's happening within 5 kilometers of the center of Dhaka, which is even slower and slightly more congested than Dhaka overall. So actually using Google Maps travel time data that we've collected with Protoya Akbar, with Victor Couture and Adam Storigard, we can do a series of comparisons using World Bank income groups for the cities depending on their country. So one thing to notice is that we don't have that many cities that are in low-income countries. for data quality reasons. What you need to keep in mind is that high income is about $47,000 per year GDP per capita. Upper middle income is 16,000, lower middle income is 6,000, and low income is about 2,000. So actually, when we lump the cities together, travel speeds are going to be relative to the world average, about 10% higher in high-income countries. Upper middle income is about the world average. Lower middle income and low income are 13% slower than the world average. So when you actually try to convert those numbers into an elasticity, the elasticity of travel speed in cities with respect to GDP is about 0.13. So big differences in travel speeds. Then when we look at how do people move around, in the US, looking again at the National Household Travel Survey, private vehicles represent 83% of trips and an astounding 97% of the mileage. And travel vehicles are basically cars and small trucks. Transit in the US is less than 2% of all trips, and a lot of those 2% actually is New York City. In the UK, a reasonably similar travel survey is telling us that private vehicles represent 60% of trips and 80% of the mileage. Transit is only 8% of all trips. So even if you have those red buses everywhere, we're seemingly well in England, actually they only represent a small share of all travel. So even in a country which is less car-oriented than the US, cars are really, really important. In urban India, cars and rickshaws represent only about 10% of trips and 10% of the mileage. Transit is 13% of all trips, but 30% of the mileage. So those overall crowded trains actually carry people quite a long way. Then walking is 25% of trips, but only 4% of the mileage. And really importantly, motorbikes are 40% of trips and 50% of the mileage. So conclusion of all that, and this goes beyond those three travel surveys, I think, cars dominate travel in the rich world and not only in the US. Motorbikes represent a really high share of all motorized vehicles throughout the developing world, 50 to 80% of the mileage, and people also walk a lot in developing cities. So let's look now at the quantity of infrastructure. Let's look at the infrastructure, first quantity and then quality. So if I look at high-income countries, there's about 1.7 kilometers of principal road, i.e. highway, primary road or secondary road, all those roads that could be used as arterioles for commutes and travel. So that's 1.7 kilometer per square kilometer. And you see that these upper middle income countries are about the same, but lower middle are much lower, and low income countries are also much lower. If we look at the total amount of roadway, there's still a difference, but you see that this difference is far less because even in poor countries, there's lots of residential roads and so on and so forth. But when I do the same calculation now by population, so these are meters of roadway per person, you see that in high-income countries, it's close to a meter. Actually, there's a big gap between the US and other rich countries, Europe and some parts of Asia, mostly. And upper middle, there's much less now. Lower middle, there's even less, and low income, even less. So basically, cities in poor countries have much less principal roadway per area, per person, and as share of total roadway. They also have less total roadway per person due to cities in the developing world being of much higher density. So these differences, at some level, we should expect them. It doesn't mean that the world is inefficient. Roads are really expensive to build using public money, and actually driving fast on fast roads is also very expensive for travelers in the developing world. So finding some differences actually may not be that surprising, and you can make the case that we've made with Eric Guerra and Chinyuma, which is that actually in the US there's probably too much too many roads, the US metropolitan areas almost surely are overpaved. So the issue is actually more about allowing for urban expansion in cities of the developing world, and as cities expand and grow and gain population, also develop their infrastructure. If we look at road quality, so that's an issue because here we're only looking at paving. There are many dimensions to road quality, which are red lights and traffic management and so on and so forth. Problem with paving in OpenStreetMap is that it's not always well reported. So here this is the ratio of paved roads relative to well-paved roads relative to all roads. So in high-income countries, it's close to 100%. Yes, in the center of European countries, you still have cobblestones and stuff like that, but it's close to 100. And you see that it is much less, especially in low-income countries, knowing that I suspect that the reporting bias actually probably leads to an understatement of those differences, as in poorer parts of the world, the roads that are reported as being with the quality well of pavement are probably the roads that have higher quality pavements. Then let's also look at the way the network will looks like. So when you look at the one indicator is how grid-like your road network may be. How close do you come to a perfect grid from 0 to 1? So you see that high-income countries are slightly higher than the rest of the world, but this is mostly an effect of US cities being particularly grid-like. Then when we take a measure of entropy, you see that we're not seeing much differences at all depending on income levels. And then when we look at circuitry, which is how much more you have to drive relative to the straight line distance between origin and destination, you see that actually, if anything, there's more circuitry in richer places. More circuitry means probably that there's actually more active traffic management, where some roads are single direction roads, and that's probably helping the flow, that's probably helping those places actually being faster. Let's give you some illustration of what those places actually look like. So at the top, that's Spokane in Washington State in the US. So that's a really grid-like city, right, despite some complications in the geography. What's darker are the principal roads, and what's lighter is everything else. Another city that looks much more messy is Kigali in Rwanda. Kigali has actually a really complicated geography, so that may not be very surprising. But so here we have a rich grid-like city and a poor messy city. But you know, we could also look at Charleroi in Belgium, that's from the rich world and incredibly ungrid-like, versus Ciudad Obregón in Mexico, which is much more grid-like and very well organized. So you see actually there's no big differences. We can see grid and non-grid everywhere. So now when we compute a speed index for every one all over city and regress that on a bunch of city characteristics, with city and country characteristics. In the first line here, with the first column here, sorry, that's just regressing the speed index on country GDP. That's this elasticity of 13% that I already reported to you before. And now when we include more city characteristics in the regression, you see that the effect of GDP goes down by quite a bit. So it means that the effect of GDP actually is going to be, well, for instance, going through the effect of road lengths, i.e. places with more roads tend to be faster, places with more grid-like network tend to be faster, places with a more difficult geography tend to be slower, and really importantly, more populated cities, all else equal, tend to be more crowded, people are fighting for space, and they tend to be slower, whereas places with a bigger land area tend to be faster. So explaining actually the differences between rich and poor countries, that's really the fact that cities in the rich world tend to be much more physically expensive and tend to have also a lot more roads. So let's turn now to the second part and talk in my second half about urban well congestion. So in a previous paper, we define well congestion as the ratio of actual travel time divided by what would be that travel time under lack of congestion, uncongested, free flow. I take all those terms to be synonymous. So when we log that expression, log congestion is going to be equal to log travel time minus log uncongested travel time. That's pretty straightforward, but slightly less straightforward. You can actually take away distance, and that's going to be the difference between log free flow uncongested speed minus log speed. We're going to average that to 0 for the whole world, knowing that we want to keep in mind that everywhere, on average, actually peak hours tend to be about 25% slower than free flow in the world. So if we look at the top first, in terms of congestion by income class, we find that high-income countries are slightly more congested and low-income countries are slightly or less well congested. But you see, when we plot that, we're seeing this picture. So here what we're doing it at the country level, where we average for the country the congestion of all the cities that are in this country. So you see at the poor end of our spectrum here, we have Ethiopia, well Tanzania, well Nigeria, well Pakistan, and those places are on average less congested than the rest of the world, but you see that there's some sort of plateau at the level of some upper middle income well countries, and then it plateaus everywhere. So you see that this is what well congestion well looks like across cities, but averaged by country. Then, since we wrote that log congestion was equal to log free flow minus log speed, we can do a variance decomposition. And what we can see is that for all countries in the world, actually, most of the variance in travel speed is explained by differences in free flow speed, uncongested speed. Very little is explained by the congestion factor, and there's essentially a very, very tiny covariance term. So it means that most of the differences at the world level between fast and slow places is really going to come from differences in uncongested speed as opposed to differences in congestion. You're going to tell me, yes, but there's you're going to compare like trips in remote suburbs that are never congested and so on and so forth. So let's actually look only at peak hour radial trips, i.e. trips going back and forth to the center. You see that we're still finding the same sort of numbers. Looking at trips, only at trips close to the center, we're still finding the same numbers. Then, when we focus on groups of countries, so of course those countries you will have the fast well countries in high income. So then among those fast countries, the congestion factor still plays a small role, but you see that in poorer places it plays a bigger role, but it's still smaller than uncongested speed. What's interesting here is also, at least for high income and middle income well countries, there's a negative correlation between negative well covariance term, which means that cities that are generally slow are also more congested. Think about Spokane in Washington State, that's going to be a very fast place, versus, let's say, New York City, which even at uncongested time is actually pretty slow to navigate. So the main point is nonetheless that congestion, yes, it's a problem for urban transportation in cities, including cities in developing countries, but at some level, this is not the problem. This is not what explained this big wedge that I had initially of, let's say, 1 to 2, 1 to 3 between really slow places in the developing world and much faster cities for travel in the rich world. So it's not about well congestion. Mostly it's actually about the quality of the infrastructure. It's about free flow speed, uncongested speed. So looking, actually, I already showed you these first two columns. I suggest we skip these two and focus only on congestion. So what we find again is a slow increase in congestion with country GDP. When we add more explanatory well factors, actually this term goes up slightly. What's interesting here is that places that have more population, all else equal, tend to be more congested. Places that expand physically more tend to be slightly less congested. Places, importantly, that have a more grid-like web network tend to be less congested. Places with a more difficult geography tend to be more congested. Nonetheless, I think the most important result in this column is this one. Places that have more roads, more principal roads, more major roads, are not significantly less congested. So it means that there's a law of congestion that seems to be well applying here, where at least, it's not causal. Well, of course, we don't have a good instrument for that here, but, places that have more roads are not significantly less congested. So okay, that was like really big picture stuff. Let's look now at 3 cities or 3 studies that look at 3 different cities, which are all highly congested cities. So the first one is actually Gabriel's paper that just showed up in Econometrica about, well, Bangalore in India. So he's doing something that is absolutely extraordinary. He's managed to organize a random, well-controlled trial on congestion pricing in that city. So he's built an app and he's managed to give financial incentive to drivers where people are being paid some amounts to leave earlier, leave later, and also some amounts to avoid certain parts of the city. So that allows him to assess the value of scheduling and the value of travel time. So what does he find? He finds moderate susceptibility across the departure time. So by actually bribing people or taxing people, you can actually lead them to substitute hours some. And he also finds a really high value of travel times, a multiple of the wage, as opposed to the recommended values of half the wage to the wage, perhaps because people really dislike driving in Bangalore, or perhaps more likely to me, drivers overestimate the time losses of alternative routes, so they tend to overestimate, meaning that actually we end up finding a high value of time. Or perhaps there's also a risk aversion to new routes, so people are reluctant to take those options where they actually get some money not to travel to those areas because they are uncertain about how much more time avoiding them is going to take them. So he also combines, so he's also using the data that he's getting from his app to Google Maps to estimate a congestion elasticity. So he's finding a modest congestion externality and no evidence of actually this externality becoming really, really large. At some point, if it's only one road, you keep adding cars and travel speed will go down to zero, i.e. the congestion externality will go to infinity. Is not finding anything that looks remotely like this, even though the place is highly congested. So overall, is finding modest gains from congestion pricing. In some work that we had a draft some years ago and then decided to work more on it with Protoy Akbar, we combined the travel survey in Bogota with Google Maps to estimate the congestion elasticity for that city using a variety of identification strategies. So our main finding is that the congestion elasticity is close to zero at night. So if you have 500 cars in Bogota, having 550 cars is not going to change anything. Then we find moderate road congestion, i.e. an elasticity of about 0.2 during transition hours, 6 in the morning, 9, 10 in the morning, 4 p.m., 3 p.m., and 8, 9 p.m. at night. But at the absolute peak hours of 7 to 9 a.m. and 5 to 7 p.m., we're actually finding a pretty modest congestion elasticity of about 5%. So to explain this seemingly bizarre result, we propose a model where drivers arbitrage between fast and congestible roads. These are the highways and the main arterials. And when they get really clogged, they actually move to slow roads that are less congestible just because there are lots and lots of them. So to verify this explanation, we use data about traffic measurements at major intersections and estimate a throughput elasticity, i.e. how many more or fewer cars go through those major intersections on major roads, depending on the total number of vehicles traveling in the city. So for the number of vehicles, we find a reasonably low throughput elasticity to the order of 0.3, 0.4, whereas for passengers, we find a much higher elasticity, much closer to 1, because as traffic increases in the city, through the main arterials, you have buses that are bigger and more full of people. So the important implications of all this is that road pricing perhaps should not be taking place at the level of the entire city, i.e. no cordon, because what it's going to do is it's going to take people away from the local roads, but maybe not do much to the highway that will remain well preferred and very well congested. So in that case, what you want to do is actually tax the places that are highly congested, the roads that are highly congested, as opposed to have a cordon. Then I'm also doing some work that is ongoing in Manila. In the interest of time, let's keep the technical details. We're trying to see if congestion in Manila is more like a few bottlenecks that create a huge amount of congestion that sort of radiates a stream. For instance, if you know, like Chicago in the morning, coming from the north, you have a bottleneck to enter the city, and you have this huge traffic jam that builds up and moves north with traffic. In Manila, we're not seeing anything that remotely like this. We have lots and lots of peaks of congestion, maybe 100 of them, so it's many bottlenecks. So congestion looks like it's more frictional in nature. So it means that in terms of policy, it means that fixing a few bottlenecks, which is what's advocated by some interest groups in the US, is not going to improve traffic conditions by much. So, instead of managing supply, maybe we should be managing demand, i.e. use price instruments. This would be the natural things to do, and most economists would immediately jump on that, of course. The problem is that we're seeing only 5 or 6 places in the world that really have something that looks like road pricing, and they're all in the rich world. So why is that? First, road pricing is technically hard to implement. It's extremely costly. Even a simple cordon, you need a lot of technology. Road pricing has winners and losers, and it looks like the losers, it's many of them, and they have a lot of political power, so they manage to kill all the expressions of interest in road pricing. Then, and if you believe with the literature I just highlighted, there's the benefits are reasonably small. So it means that what should we do in that case? We should be doing perhaps more research to understand also the other externalities associated with traffic. How they work in space, pollution, noise, accidents, and all that. We should try maybe to do like London back in the day, and what's also showing up in a recent working paper, where you want to bundle congestion charging with other policies. There are also a substitute for road pricing, like parking pricing, and you should perhaps avoid policies that are not very useful. One of them may be quantity instruments. So here, those quantity instruments are restrictions based on the vehicle, its plate number, its occupancy, the type of vehicle, its age, and so on and so forth. So let's think about mostly place-based restrictions. They are all over the map, literally in the world. Many places use them. The literature is a bit divided. Some of the research finds that those restrictions are effective at reducing traffic. It may not be welfare when improving, whereas others are a lot more skeptical. So count me in that skeptical camp, because I think plate restrictions. Yeah, I need 5 more seconds. So my conclusion here is that these place restrictions lead people to conduct their errands at less preferred time in less preferred locations, but that's not changing the total amount of traffic. And there is a debate, but I think those restrictions also probably lead households to buy more cars. So I'm going to finish here. I have some suggestions for further research, but I think I will keep that for the discussion later.
Great. I'm going to jump right in and continue. Thank you very much, Gilles. Thank you very much, everyone who's organizing. And it's, as Gilles said, it's wonderful to see so many of you here. I'm going to talk about public transit, an important part of providing urban mobility, as well as broader impacts of having urban mobility. I'm going to focus on low and middle income countries throughout this. So for context for public transit, and this is building on some of the descriptive evidence that Gilles has already mentioned on how people travel. How people travel is changing extremely fast in developing countries. So this is the stock of vehicles in India, and you can see just this massive growth over time. And this is true in country after country after country. A lot of these are motorcycles, which, as Gilles mentions, are super interesting and understudied. And by comparison, I believe this is around zero for a country like the US. So this is why it's important to understand public transit, because it's hard to imagine a sustainable urban mobility without mass transit, without being able to move a lot of people in a few vehicles around, although we don't know what the future can bring. So how is this achieved in low and middle countries? And somewhat characteristic for developing countries, there are essentially two technologies in some sense of providing shared transportation, if we want to call it this way. And one of them is privately provided. And this is prevalent, the prevalent way that we see people moving around in poorer countries. This is when the state doesn't have the capacity to provide public transport by itself. And so there's a private market that kicks in. This is used by hundreds of millions of people all over sub-Saharan Africa and other countries as well. Usually, there are a few features that we believe are common across settings. We don't have excellent data about it, but we think it's usually one owner that gives out the vehicle to a driver. The driver pays a fixed fee and then keeps the revenue. In many settings, these small firms are organized into associations. And these associations try to act as local monopolies, like over their routes that they control. They sometimes fight, they sometimes have territories over this. This whole industry is sometimes called informal, and this is, I believe, a bit of a misnomer, because in many settings, these associations are recognized. Drivers actually need to have some kind of permit in order to run a route, and they are either regulated somewhat or sometimes even taxed by the state. They're thought to be, other than a private market, which might be responsive to demand, somewhat expensive, a consequence of the monopoly part, and this being very profit-driven, unreliable in time sometimes, and unsafe. I'll have a little bit to say about that. And of course, more and more countries and city governments are moving towards publicly provided provision of transport. This often takes the form of bus rapid transit systems. So these are buses that have dedicated lanes and where stations are a little bit like subways. So people pay first and then get on the bus. And this mode of transport offers many of the benefits of things like subways and light rail at a fraction of the cost. And so that's why it's been so popular and continues to be so in countries that might afford less the construction of those heavier options. So let's go a little bit, I'm going to go kind of high level over a little bit what we know about these two technologies of providing public transport. But first, I want to do some teaser with showing you just how prevalent it is to have this privately provided public transport. So in Mexico City, it's going to be Pecero, Combi, Micro, or Microbus. But you see it in Senegal, where it's called Car Rapid or Afto. In Kenya, these are called matatus. In Lagos, it's Danfoss. South Africa, minibus, and I could go on, and I'm sure you can as well. In Jakarta, these are called angkot. It turns out we know something, a few bits of information about how these industries and markets work, but not a lot. So one paper that's super interesting thinks about the contracting issues, the agency issues that arise between owners and drivers. because owners of these minibuses cannot observe how many passengers board, so they don't observe revenue, they're limited in the types of contracts that they can offer to drivers. And so usually the driver pays a fixed fee to the owner and then keeps everything that they make in terms of revenue from passengers. So this paper by Erin Kelly and co-authors is an experiment where they provide to owners better data through GPS trackers on these buses. So it's not perfect data, but it's a little bit better. And they see how the contract between owners and drivers change. This matters because these drivers are very highly incentivized to make money, and so that might be that is kind of connected with some of the behaviors that we don't like about them, such as driving very fast, unsafe, and sometimes related to violence. There's a bit of a paradox here, which is that although at some level we think this industry on routes acts as monopolists, these monopoly rents may actually be dissipated by competition at some level between these drivers. So at the same time, we think that prices are too high, but also that these drivers might not be making huge margins, and so that might be pushing them to drive so aggressively. Related to this important issue of safety, and many crashes in many settings are because of these minibuses. There's interest in what kind of interventions can make minibuses safer. Habyarimana and Jack have a landmark paper showing that a simple intervention that puts a sticker that encourages passengers to speak up and ask drivers to drive more safely actually works to reduce accidents as measured from insurance data. This is an experiment in Kenya. And it's one of the few. Erin Kelly has follow-up work also on safety with Greg Lane and others, but we need to know much more. In terms of the actual market provision of transport, there are a few papers. So Lucas Conwell focuses on the ubiquitous way that these markets operate, which is that buses first fill up and then leave, rather than being on some kind of schedule or just passing through a station and keep going. That's by itself somewhat inefficient, and he uses a queuing model and very precise data he collected in Cape Town to quantify externalities related to frequency. So when more buses travel or when more people come to the station, that makes wait times smaller for everyone else. And that's actually something he argues they don't internalize. Oluchi Mbonu is a graduate student on the job market from Harvard this year. And she looks at a new angle, which is between association. Let's understand how well they work together. Now, why would you want that? So she shows that in Johannesburg, these associations actually divide the whole city into territories, essentially, which they mostly control. However, demand for travel in the city is much more interconnected. So a quarter of people travel between territories. And so that's why it's important to understand how those routes that have to be negotiated between pairs of associations are able to serve travelers. And she shows that they're not very good. They're less responsive when demand shocks happen. They also seem to be highly profitable at the margin, which suggests that it's very costly to establish them and to maintain them. Dan Bjorkegren and others are looking in Nigeria and Lagos on how, a very interesting question, as cities launch government operated transit, how will these markets respond? In some settings, they respond by opposing these changes to begin with, sometimes violently. But when it happens, it's important to understand whether these private markets are actually going to fill some kind of gap, for example, acting as feeders to government provided public transit, or not. And this is what they look at. In general, I would say we need a lot more work on these complex market structures, both to understand whether to improve them at the margin through policy, but also to understand their shortcomings as they're changing. Shifting over to public transit, so this is provided by the government. This is something that's increasingly common, and we expect to see as countries become richer. So here you see the launching of BRT system, these bus rapid transit system with dedicated lanes. It's really been growing. It's plateaued a little bit even before COVID, which is kind of interesting. But the growth between 2000 and 2020 has been really tremendous in low and middle income countries. Sub-Saharan Africa has still not caught up, but we can expect this is gonna come up. So what do we know about the system or publicly provided public transport more generally? Now I'm going to start with a paper that kind of zooms out and shows that in principle these systems can have tremendous benefits. I'm going to connect a little bit here with what Gilles was saying about understanding other types of costs of private travel. So this paper by Nicolas Gendron-Carrier and co-authors asks what subway system launches do to air pollution. And they argue that they show that in cities that are baseline very polluted, launching a subway system reduces pollution. So this is what this graph shows. It's an interesting type of graph where each point denotes a city, and we're looking at the impact in that city when it launched its subway system. And you see on the x-axis the coefficient. So this is a reduction, say 5%, but also the standard error. So these points over here indicate a statistically significant reduction at the city level. We do have some estimates of increases in air pollution, which might be at some level some noise, but on average there are more points on kind of on the left side. Now, there's a different paper that focuses on China and has very detailed road traffic speed data that shows that when subway systems expand, road traffic congestion goes down, and that's kind of a plausible mechanism for what we're seeing here. And again, linking to what Gilles was saying, the value of these reductions in air pollution can be absolutely enormous. This original paper does several kind of back of the envelope calculations. I adapted one of them for a paper that I'm working on that I'll mention in a bit. In Jakarta, 1 percentage point modal shift to non-polluting modes, let's say public transit, has a value that's 4 times larger than the congestion benefits that we estimate. And this is a conservative estimate of these health effects. There's a different set of estimates, which is 20 times larger. So these health benefits can just be enormous. Okay, so subways can affect air pollution. It turns out we don't have evidence that they affect growth or population. This is a subset of authors in a previous paper looking at all of the subway launches in the world and nighttime lights and data on population for different cities. We just don't see it, right? There's some decentralization effect, which you might expect, but on average, these cities becoming more productive or more attractive does not seem to be something that we find. Now, I want to make an important point, which is that these government-provided public transit systems can be hit or miss. And when they're successful, they can be amazing. And I think the Bogota is the leading example of that, where very recently, Transmilenio has this huge modal share among motorized trips. I hope I have this right, but Gilles can correct me otherwise. And where researchers like Nick Tivanidis have analyzed how launching this type of system really reconfigures the entire city in terms of where people live and where they work, where they commute to, and general equilibrium quantities like wages and rents. But this is not the only story that's possible. And another paper by Arya Gadu and co-authors looks at Jakarta, which has its own claim to fame with the largest BRT system in the world. The fine print is that this is by size. So it has the longest, the most number of kilometers and so on. This launched in 2004. The authors use really cool data, the very large scale household surveys collected by JICA before and after the launch of the Trans-Jakarta. And across a number of specifications, they don't find anything in terms of even public transport. In fact, they argue that converting road lanes from space that can be used by private vehicles to BRT increased traffic congestion. And they show that in a few specifications. So this suggests that the design of these systems matters quite a bit. What's going in Jakarta, this is one of my favorite graphs about urban mobility in this region. So these are 3 time periods, 2002, 2010, and 2018. You see these, and these are mode shares, right, of different modes. You see a massive, massive shift away from the old type of buses that we talked about before to motorcycles. And again, this is Gilles' point that I think this mode, understanding the benefits, but also the costs of these modes is still understudied compared to what we should. Transjakarta, this largest BRT system in the world, here it is. Okay, this is for an area that's around 30 million people, and so Transjakarta is concentrated in its city center, but still, this is very low. Let's go a bit back to basic economics and a bit of theory. So, and think about how should governments design these public transport systems? Because there are many dilemmas that central planners, which is what they are, they become central planners, have to solve in these settings. One of them is how to choose prices. And in particular, should the government, or how much should the government subsidize public transit? So I want to go briefly through some of the economic motivations for doing so. A leading one is that providing a transport network is like an industry with increasing returns to scale. And what do we know about efficient pricing in this type of economic setting? From Herbert Moring in 1972, we know that the prices should be set at the short-term marginal cost. So how much does it cost for the whole city of Jakarta, for example, to provide an additional trip? That's what prices should be. And that might be quite low. But because of the increasing returns to scale, there will be a budget shortfall. Right? So the operator won't be able to recoup its cost, but it should be subsidized, or it should be funded by the government and through some taxes. That is really the efficient way to price these goods. And this is different from other reasons to subsidize public transit, because of traffic externalities, because of positive spillovers when more people travel, or because of equity considerations. And this is still something that, to my knowledge, we don't know very much, both understanding these marginal costs and the degree of returns to scale. The subways and air pollution paper that I mentioned has a little bit on increasing returns to scale, but really not a lot. On the other side, in terms of pricing, we know also not a great deal about elasticity, price elasticities. This paper by Lucas Davis shows, basically looks at subways and when they change their fares and how aggregate ridership changes, and finds pretty moderate price elasticities. So in practice, this probably matters. But prices is not the only margin that planners need to decide. They also need to decide where these networks go. What do they cover? And we look at this in a recent paper in Jakarta. What we do is we estimate how commuters care about different attributes that are related to the shape of the network. So depending on how you design the network, it's going to affect wait times, bus times, and whether people need to make transfers. And so we use this expansion over time to understand, to estimate how people care about these dimensions. Turns out people care a lot about wait times, not so much about transfers in this setting. And we have a framework to describe what optimal policies look like, and that allows us to make very nice graphs like this one. So this is the current Transjakarta network and its frequency map. And with our model, we can say networks should look a little bit more like this to maximize commuter welfare. They should be a little bit more expansive and a little bit less concentrated. So that's what I have to add for public transit. The takeaways is, I think we do need more research to understand how privatized markets of public transit function, and also how governments, as they are taking a more active role in managing these systems, can do so successfully to provide mobility. Which leads me to the last part of this lecture, which is we've been talking about how to provide urban mobility, what are the determinants of it in many ways, speed, public transit, and so on. But what does it do to other outcomes, other economic and other outcomes? So I'm going to focus here on labor markets and education. That's not to say, not to diminish the importance of all the other reasons why people travel, but this is where the research is focused and concentrated. And I'm going to take a more micro approach to it. So the thought experiment you have in mind for the first part is, what happens if one person gets access to better mobility for, think about it, for a long period of time, right? And better here is something that should be comprehensive. It could be faster travel, it could be cheaper, it could be safer or more comfortable. So we're going to look at several papers that approximate this type of experiment. And then I'm going to briefly mention what we know about how access to transportation within the city interacts with search and labor market dynamics, where people look for jobs and especially for good jobs. These exercises are not without caveats. So think about if one person gets better transportation and we see that they have better jobs, this may be in part because of some kind of displacement. So this might be that other people are less likely now to get those jobs. But some of the effect is probably real in that when cities become overall more connected, economic activity overall goes up. But that's really difficult to estimate. Those kinds of aggregate effects with the types of methods that I'll show you here, it's really hard to do RCTs at that kind of level. So interestingly, the paper that I'm aware of that it comes closest to this ideal experiment of providing people with better mobility has kind of a different pitch, thinks about motorcycles as credit constraints. This is a paper by Van Doornik et al., recently published in the AER. And they look at what happens when people own a motorcycle. They think about it as something that increases market access to jobs. And they also believe or are going to argue that it's an investment and people are credit constrained. They're not able to invest optimally in this technology. How do they do this? Well, they use some very clever random variation, looking at rotating credit groups. So these are groups of people who get together, they all want to buy a motorcycle each, and they save jointly in order to do so. And the way these credit groups work is that they meet monthly, and every month, everybody puts in the same amount of money. That money gets pooled, and then one person who's randomly selected is going to actually get all the money and be able to buy the motorcycle at that point. And then, they have to keep meeting and keep contributing to this group. So this is great because of this lottery that's going to be very useful for identification. These are very popular in Brazil, the setting of this study. And so they use data on 3.4 million consortius participants. They link it with formal employment data. And they use a staggered differences in difference using this random variation from lotteries. So let's see what happens. Well, the first, I'm going to start with a caveat for the results in this paper, which is they only have access to formal employment data. And that actually goes up. So the baseline is around 37% of participants in these credit groups are formal. That goes up not by a huge amount, by 2%. That's good in and of itself because we think these are better jobs, but it also is going to be a slight selection issue with the next set of results. So commuting distance among formal workers goes up, and it goes up significantly by 15-20% after a few years, after someone essentially is able to buy a motorcycle relative to people who don't have one yet. Interestingly, they also go to jobs that were previously much more difficult to access. So their workplace is further away from public transit. Okay? And finally, they earn more, again, in the formal sector. These effects are large, right? So formal sector salaries go up by 10%. So overall, despite the limitations of only being able to look at the formal sector and not knowing what happens in the informal sector, this paper suggests there may be quite big individual level effects from mobility. Now, as I mentioned at the beginning, it doesn't have to be speed or accessibility only. There are other dimensions of travel costs that are really important. Girija Borkar has a paper that looks at educational choices, so the quality of colleges that people go to, and asks whether women end up choosing lower quality universities because of the safety or the risks associated with commuting there. And she'll argue that that's very much the case. Her setting is Delhi, where sexual harassment risk is just extremely widespread, and large majorities of women say they avoid places because they're risky or they're afraid of being out in public spaces. But it also varies a lot by travel mode and by area of the city. It's also a centralized setting where admissions depend on scores. And so she has all of this information. So she knows all of the colleges that a certain person, man or woman, could in principle go to. And then she uses a discrete choice model to say, well, some people have kind of safe routes to good colleges or unsafe routes to good colleges. And there's a lot of variation there in accessibility and safety. I'm just going to give you the punchline. There's a huge safety penalty for women, and this is compared to men. So one way to digest her results is that if you get a one standard deviation increase in the safety of a route, women would choose that, or they trade off quality in such a way that you would see someone going from the bottom 50% of the quality distribution to the top 20%. And there are other papers in this space. The thing that I want to end with in the last couple of minutes is thinking about how transportation interacts even more finely with search in the labor market. This is because this is a particular time in people's careers when they may be liquidity constrained and yet might benefit a lot from traveling in order to understand where jobs are. So there are a few really cool studies that look at this. Simon Franklin has an experiment giving transport subsidies in Addis Ababa for people to go to the city center where there are job boards with formal, better jobs. And he finds that there's a short-term increase in search intensity. People are more likely to work and also a little bit more likely to work and a little bit more likely to hold better jobs, so office jobs or more permanent jobs and so on. There's a follow-up study in the same setting, which is able to look at these kinds of effects over a much longer run. So after 4 years, it turns out that the effects of these types of transport subsidies have already dissipated. One possible explanation is that people in the control eventually get kind of a decent job match as well if they can, but it might take them more time. This is unlike other job search interventions. So maybe the transportation subsidies, it seems, are not a silver bullet in terms of job search in this market. Abhijit Banerjee and Sandra Sekera have a kind of highly related paper that makes a very interesting point. They show that job seekers at the beginning of their career are super optimistic about their prospects in the job market, and giving them a transport subsidy leads them to search more, and that itself leads them to learn more about kind of the true probabilities of them getting different types of jobs. This has some pretty nuanced labor market effects, which is something that appears in other settings. But it's kind of a different way of thinking of what transport does. It allows you to learn about the city, about you, and about these matches. I'm also going to mention a paper that I'm working on that is going to be ready very soon, where we take a very different perspective for search. What we show here is that in the context of casual workers in Nairobi, people are very reluctant to go to a neighborhood where they've never been. In Equilibrium, they've never been to an important share of neighborhoods that are objectively accessible. And so these kind of first-time exploration costs, we argue, may be quite important for how people interact and their mobility in cities. I'm going to stop here, and I think we're going to go to Q&A. Thank you.
Thank you so much, Gabriel and Gilles, for the wonderful insights. I think we've all learned a lot from the last hour, and I can see by the brilliant questions coming through in the chat that there's a lot of engagement on this. So we're going to do our best to get to some of these questions. I'm going to pose one from the chat now, but I would love to ask the live participants to please raise your hands if you would like to come in and ask a question live, or anyone else in the audience that wants to be brought in. And Aman, if you could make sure that they're able to come in and unmute and put their cameras on. But before we turn to that, there's one question in the chat from Jerome Videja that says, One of the more popular notions to solve traffic congestion within cities is to spread out economic opportunities and develop other areas. To what extent has the emergence of smaller nearby cities led to the decongestion of major cities? Does it really change traffic or more like redistribute it? So if you could tackle that question first, and then we'll come to some of the live participants.
Let's solve all the big urban development questions all at once. I wanted to flag this one because I thought it was a great question, and it actually shows the whole complexity on why this class is actually taking place online with many different modules, because this question actually goes to different modules. Because if you spread things out, which is not easy, there will be this trade-off between less congestion maybe, but also less agglomeration. And we don't really know how those things really work within cities. So that's, it looks like in practice, very large, well-functioning metropolitan areas have a main center that carries some weight, a lot of weight in the case of New York, less weight in the case of LA, but some weight. And even in the case of New York, a bunch of sub-centers around, some of them close by, some of them further away. The idea that, yes, everybody should be commuting to a single center as soon as velocity exceeds, let's say, 3, 4, 5 million is a recipe for disaster. But what is the optimal way to organize a city, spreading out sub-centers, main center, and so on and so forth? I don't think we know that. We have some models that give some answers, but in practice, I don't think we know that.
Absolutely. And let me add just one very quick, slightly different way of saying exactly the same thing, which is there are negative externalities and positive externalities. So you'd want to think in a Pigouvian sense, what is the net externality from living in a large versus medium city, and impose those and see kind of where we go, but that seems hard.
Great. Thank you both. I'm going to bring in Alexis and then James to ask their questions.
Hello, thank you very much for the lecture. It was very interesting. I have 2 questions, one for Sir Duranton and one for Professor Kreindler. Firstly, Professor Duranton, you've talked a lot about the fact that a grid-like structure is very important for the speed of cars. And I'm asking myself, is it the fact that it is a grid, or the fact that it is structured in the sense, would, for example, a city that looked like a target where you have circles and then maybe roads that cross a circle, would that be as effective, or is the grid structure a more efficient way of structuring your city to make your traffic go faster? And then for Professor Kreindler, I was seeing in the paper you made about Jakarta and the optimal structure, transport structure, there were loads of radial lines that went from a suburb to the city center, but I didn't see that many, how to say, like sideway connections where you would go around the city or not exactly through a city. Are those connections also important? If yes, when are they important and when should they be implemented? Thank you very much.
Great. James, do you want to ask your question as well, and then we can come to both of them? I hope Jill and Gabriel, you're able to remember the length of questions. But James, come in with yours as well.
Yes, thank you very much. And thank you, professors, both for this lecture today. My question was actually about outcomes and public transit uptake following COVID. Here in the United States, for example, we saw that there was significantly less uptake of public transit during COVID. And then even following this, a lot of agencies reduced service. And then the uptake is that the return to pre-pandemic service is actually quite slow. And in particular, Professor Kreindler, you were talking about a lot of these individual effects with respect to access to transit. I'm wondering if we now know any new information about whether or not usage of public transit decreased and has recovered in developing countries, and whether or not these individual outcomes might have changed with respect to access. Thank you.
Great. I don't know who wants to tackle those questions first.
Gilles, do you want to go first with the grid structure?
Yes, not the easiest of questions. Thank you for raising it. Here we're doing some pretty high-level regressions, and we've been trying a combination of things. We've been asked by referees to try even more, which is fair game. And the one thing that stands out is indeed this measure of how grid-like you are. Whether the effect is completely causal, I don't know. There might be some underlying factors that will explain at the same time, better mobility and a more grid-like structure. For instance, in some developing countries, French colonizers have had a tendency, according to Vernon Henderson, to actually be more concerned with urban planning, and that might have affected driving conditions in a way that, through some characteristics that we don't know about. So what we're trying to do here is basically saying, look, there's something really interesting going on with reasonably large, non-trivial effects, and it would be really, really great to know more well about that. And I think, again, this is where people focusing on some particular variation, either within one city, which seems to be hard, or multiple cities, to actually explore that in greater depth. Here we try, again, it's a pretty macro sort of work, so we cannot really enter all the details and subtleties. We're basically saying, look, there's something interesting there's something interesting in here, and so on and so forth. Let's pay attention to that. Here are the big associations in the data. Whether other forms of road organizations, like concentric roads, help as well, maybe. They're not super prevalent, so the ring roads that are being built in many parts of the world, like the first, the second, third, and so on and so forth, tend to be more roundish in shapes than grid-like. Yes, that's also maybe something that where somebody wants to gather some data and actually try to do something with it. I mean, you want to gather data, and for that have some sort of sense of what could be a reasonable source of exogenous variation. Gathering data, I think I know how to do that. The second question, I have no idea how to answer it, but hopefully among you there'll be somebody with a good idea.
I can jump in for Alexis. Thanks. That's a really good observation about sideline connections, or the not having many of those. A few points. In our exercise in Jakarta, our counterfactuals are holding fixed where people are traveling right now. And we have that from smartphone location data. And so for those patterns, that's kind of the types of solutions that we get. I think just an important force in that is that when you have overlapping routes, people can take any number of routes, any number of the buses, and so wait times go down a lot. And so that is a force towards concentrating, both where people travel now and to decrease wait times. That said, I'm not going to show it again, but actually in the center of Jakarta, there is a lot more overlap and a lot more kind of different types of routes. It's really in the periphery where, our model says that those would not be the best place to put them. James, in terms of public transport after COVID, I think that's fascinating. I actually don't know much about it. In Jakarta, I think this is picking up gradually. Like operations also went down. They closed a large number of routes, even when lockdowns were ended. And I think it's gradually going up. To me, it does remind me of something that I find fascinating and I think not studied yet enough, which is that there may be important habits or this kind of exploration in these types of decisions. So once you try something else, I mean, there are material reasons why if I buy a motorcycle, I might just stick with it. But even beyond that, I think there may be some habit forces.
Great. I'm going to bring in Letitia next, and then I think we've got a question from Victor Valola in the chat as well. I'm going to allow them to come in as well.
Thank you, Vicky. Thank you very much for the presentation, for the lectures. They were quite informative. What, in your opinion, is the most probable optimistic future for this in developing countries? And I would also like to ask about the BRT, because you mentioned that in some cities, the BRT unfortunately failed. So, and I can assume that one of the causes could have been the informal public transport. So how can these two be coordinated for an optimal public transport system? Thank you.
I think Victor might have put his hand down. So go ahead and ask answer this question, and we'll find another question after that.
Jill, I'm also very curious what you think about the optimistic future of urban mobility and public transit. So
you want me to go first? I mean, you want me to go first on that question?
on that question, if you'd like, I can take the failure of Jakarta.
Well, let me first. Actually, yeah, Jakarta looks like a failure from the evidence. Bogota is a success, like you said, Gabriel, at several levels. You know, they have a world record of probably the most efficient system ever, being able to clock like a bus every, 30 seconds. But even a bus every 30 seconds with 100 people in it, that's still a very limited rail capacity. So now we have two lines going to the south of Bogota. So there's two BRT lines going north-south. That's going to be maybe 30,000 people per hour. Knowing that the south of Bogota is mostly covered by residential areas, initially informal, so not very much space for economic activity. As a result, most of the jobs are in the north, domestic jobs, services, or in the west, manufacturing. And it's maybe 6 billion people living in the south of Bogota. So even, you know, not everybody will want to commute and stuff, but we have something that carries 30,000 people an hour for potentially more than 1 million workers, and that just doesn't work. The capacity is not quite where it should be. This is where I think subways in those cases are actually dearly, dearly needed, and there's a whole saga of subway in Bogota that we could talk about forever. So, future of cities, I don't know. To me, the challenge for everybody, rich and poor cities, is there are some new forms of mobility that have already arrived with micro-mobility, scooters, e-bikes, bicycles in some places as well, like regular bicycles. And that can be owned directly, that can be rented, and all sorts of, and organizing that turns out to be pretty hard, because the situation can get pretty messy, as we all know, pretty quickly. And then actually in Paris, people voted very strongly in favor of actually banning those rental services. So the challenge, I think, for the future is how to organize this last mile mobility, how that can be combined with longer public service type, with public transit, with type of mobility. Motorbikes are problematic in all sorts of ways, but they're very, very useful to carry a lot of people on a limited space. People really like being able to do stuff on their own. You know, like transit is an inferior good in an economic sense, right? When you get richer, you want to bail out of that and use whatever car. So here there are lots of really important questions. I know some people have very, very strong opinions about them. Personally, I'm very open, and there's lots of stuff I would want to know. You know, I have some hunches and stuff that may not be those of lots of urban planners, but I think it's really about how to organize that, and whether really having mass transportation, to what extent mass transportation is going to be really needed, in the future, where lots of other options are going to be available. Sorry, I did not answer the question, but I told you why I cannot answer your question.
Let me also say, if it's very much in agreement, I also feel like a place like Bogota, like the best case scenario is Bogota should graduate the subways. And the best case scenario is that public transit operators learn how to do their job really well, and whatever failures happen in Jakarta are kind of averted. One way that might happen is by getting a lot more data about mobility, about their operations that is happening. It's something I see in my work collaborating with Transjakarta. There's a huge interest in kind of insights and understanding the data, and that requires a lot of different moving parts. That's an optimistic scenario. Another different optimistic scenario, I think, is like Gilles highlighted. I think motorcycles can be extremely useful for mobility, and people just demand them. I think we don't know how bad they are for air pollution, but as I mentioned earlier, I think that's a huge issue for human welfare. And so a future where these are all electric is a very optimistic one, where you might have great mobility with low externalities. And the final point is, I think, and I'm trying to work on this now in Kampala, understanding better how to transition the informal systems or the privatized systems to improve them at the margin, given some of the constraints there, or how even to embed them even more into government kind of ran operated systems is super interesting, and I think an opportunity. It's mostly viewed as these systems are always opposing, they're kind of in conflict with the government, they feel threatened, but I think there's scope there for seeing what they do well.
Great. I'm going to pose one more question from the chat, and then I'm going to bring in Mansour Isani and Christian Haman to ask their questions. So first from Sharon K in the chat, are 15-minute cities the answer to congestion and possible reduction of vehicles within cities? Or should there be a transformation of roads to public walk spaces? Does that make more sense? So that's the question from the chat. And then I'm going to ask Mansour and Christian to ask their questions. And if we could keep the questions brief and the answers brief as we're nearing the closing time as well. Mansour, over to you.
Hi, am I audible?
Yes, you are.
Yes. I have a very general question about it. Like I'm living in a developing country which is struggling with the economic prosperity. And recently we have also developed some BRT programs under the GCF. But simultaneously, I have experiencing the more environment and congestion after the BRT adoption because of the very sequestrated road strips and another thing. So don't you think like the Jakarta BRT is not that much effective in the many developing countries? Secondly, the education and the awareness programs regarding the use of BRT more important prior to adoption of the BRT. I just want to ask the opinions about your experience, from your experience. Thank you.
Gilles, I'll do this again. I feel like the first two questions are very much related to land use and how. So I would pass this on to you if you don't mind.
Yes. So the 15-minute city, as understood by some urban planners in Europe. I live in Madrid now. I really like it. Yes, there's a lot of 15-minute stuff, but at the same time, it's also about being able to go beyond your immediate neighborhood. And doing that in a way that's motorized. People live complicated lives. So I'm all in favor of improving access, but at the same time, dogmas, I always have an immediate reaction saying, how do you freaking know that? I don't think you know, and I don't think they know that. Actually, there was a slide for the second part of your question that I think hopefully is going to be posted that I did not talk about because my presentation was already overlong, but it was actually framing transportation early on in the presentation as an optimal land use question. So here, again, I don't think we know the answer. We know how to frame the questions. This is an interesting, actually, strand of theory that's been trying to model that, and I think they've been very useful for me to understand what this is about and how to frame the problem. Then I don't know what the answers might be, but yes, there's an optimal roadway question which I wish we knew more about. I think this is where, the grids sort of story, those regressions where we start we're putting in the amount of roadway of different classes and so on and so forth, network variables. This is about trying to get at that in a very, very superficial way, really scratching with the surface. But yes, indeed, we would need to go much deeper, but that would require, I guess, a slightly different sort of study, maybe combine that with some modeling and so on and so forth. So there's plenty of work to do for the future.
Let me be brief about Mansour. I think great questions about BRTs. I think I'm going to say we don't know. We really don't know. So first, we don't know super well why in Jakarta it failed. There's a real trade-off with taking away road space from cars and motorcycles, but we don't know exactly why it failed so much at the beginning. And then I think these are also, I gave kind of two polar opposite examples. And I think there's research ongoing that tries to look at BRTs across the world to say more like on average, how do we think they've fared? But I don't have an answer ready.
Great. Christian, do you want to come in with your question? And then maybe just as a very broad closing question to you both, from Ali Shuba Philip, what kind of trade-offs should the planner consider for optimal transportation design? So maybe just a way to summarize, I think, some of the key points that you've made in the lecture. But Christian, over to you before we have the closing remarks.
Yeah, thanks very much for the opportunity. I guess mine is also related to a trade-off. It's a question for Gabriel. I think the idea you introduced about private public transport versus public transport is really fascinating. And in South Africa, it's a particular point that I think hasn't been explored a lot, where we have public transport. In some cities, we have BRT and we have other bus systems. And in some parts of those cities, those buses are well used. And we have in one province, we have the Gau train, the high-speed train, and there's bus systems related to it. But then sometimes, like the Gau train buses, they're nearly empty, or even sometimes you see BRT buses on the routes being nearly empty, and then those BRT routes also don't cover the spaces that one might to go. Whereas the minibus taxi systems are so much more flexible, has such much bigger coverage, a variety of routes. It's much easier to get on and off, etc. And the question for me is always, how do you analyze or understand whether it's worth government rather facilitating the minibus taxi industry rather than putting up public investment into BRT, when such a system kind of, obviously there's a political question as well, but like from a data kind of technical point, I just always wonder about that trade-off, and you have any thoughts on that. But thanks very much.
That's fascinating. Thanks very much. That's a fascinating question. I think Lucas Conwell, in his paper where he looks at Cape Town, he tries to delve into some of these questions and trade-offs. I would say density, from what I gather from his paper, is really important in that setting, right? So if you have high density, that's going to allow you to have things like BRT being very used, but in more spread out settings, you need smaller kind of vehicles ultimately.
Okay, so let me go back to the question just before. One important point is that in many parts of the world, there's always in urban planning this tension between land use planners and transportation planners. And transportation planners are about maximizing throughput, irrespective of the damage that this may create. Land use planners tend to forget that we want to be able to go to like lots of different places. And that's, for many, many years, the transportation planners had the upper hand in the rich world and many parts of the poor world. Now land use planners, I think, have recovered some clouds. So, I think, yes, we were probably too far in terms of using non-green public space for just motorized transportation. There's a backlash, but I think this backlash sometimes is going too far or is not done properly and is not always conducive to really good outcomes. So again, that's a land use question. How much land use should we be using? And among the stuff that's feasible, the land use that's not residential, not business, not green spaces, how much of that should be roads for cars versus everything else? And with the added complication in developing countries that you can say whatever you like, but sometimes it's really, really hard to actually implement well the things. So you have an equilibrium where there's some space where there's probably too much cars, but it's really, really hard to go back on that. Or some spaces where, we would need some roadway, but you have all sorts of people using that for all sorts of things that actually traffic is really, really slow and highly well impeded, and that's not efficient either. So there's a problem of how much we want to devote to which, and also how do we actually implement those decisions once they've been made.
And super briefly for me, I think it's a really difficult question. So the only thing I would say is that, reiterating what Gilles said, the objective is really important, and you don't want to reduce congestion per se. That is not the objective per se. It's not even increasing mobility, as attractive as that may be, but it's all of the opportunity costs and all of the externalities need to be in there.
Great. Unfortunately, we're now at time and need to close the discussion. I just wanted to say a really big thank you to our speakers, to Professor Duranton and Kreindler for their presentations and insights, and also a big thank you to the audience for your brilliant questions. The materials from today's lecture should be on the website by tomorrow, so please do check back at that, and we will put up the longer version of Gilles' slides so you can see some of the missing material from today. But thanks again, everyone, and we really look forward to seeing you all next week.
Thanks, everyone.
Thank you.
Bye-bye.
Thank you, everyone.
Thank you.